Okay, so we now come to task 1 in part B, which asks us to determine an exponential equation that best fits your graph. Okay, so going to go through the working for this. Okay, so for charging we want to use this exponential equation, which is one you haven't seen before. Okay, so it says V of t, the voltage depends on time, is equal to V max. Okay, V max is going to be our maximum voltage, that's 13.88. The maximum voltage the capacitor charged to, and that's times, in brackets, 1 minus b, where b is our growth factor, to the negative t, where t is time. Okay, so first thing we need to do is to calculate our growth factor, and to do that we want to look at our results. Okay, so here we have our average voltage against time. Okay, so we want to divide the second result by the first result. Okay, so I go into this cell here, I click equals, I select this cell, and I divide it by this cell. Okay, so that gives me a growth factor of 131.67, which is unusually high. Okay, so once again I want to roll over this little green box, drag it down. Okay, so that gives me all my growth factors. So you notice I start off with a growth factor of 131, and by the end I have a growth factor of 1.024. Okay, so that's a great range of growth factors. Most of them are less than 2. In fact, all of them are less than 2 except for this one. So that's what I would call an anomaly. So I just want to delete that one, get rid of it, because it's going to mess up the rest of our results. Okay, because what we want to do now is we want to find the average growth factor. Okay, so take all these results and find the average. So I'm going to find my average down here. So once again I press equals and type in the formula for average. So average in capitals, open brackets, select all these numbers, close brackets, press enter. Okay, so my average growth factor is going to be 1.09. So that's going to be this number here.